Okay, let's do page 3 of normal distribution. A machine produces washers whose diameters are normally distributed with a mean of 40 millimeters and a standard deviation of 2 millimeters. Find the probability that a washer has a diameter less than 37. I think it's always helpful to draw a picture of the normal distribution, marking the mean and the standard deviation. So let's do that. We're going to draw that the mean is 40, so the middle number is 40, and the standard deviation is 2 millimeters, and so the first line here is going to be 42 millimeters, the left line is going to be 38, and so on. So 44, 36, okay. And so they say find the probability the washer has a diameter of less than 37. Now you can see that 37 would be right there. It would start not on one of the standard deviation lines, but halfway between two standard deviation lines. Oops, I wrote 36 in the wrong place, right? 36 is going to be here. So 37 is actually halfway between those two. Okay. So since the line here, this purple line, is not on a standard deviation line, we can't use the 68, 95, 99 rule. We have to use the calculator. Okay, so let's use the calculator to figure out what this area is between negative infinity and 37, what the percentage is. So we do second dist, and then we do normal CDF, and the left boundary is going to be negative infinity, so negative 1 EE 99, and the upper limit is 37, and the mean is 40, and the standard deviation is 2, and that's it. So the probability is 0.0668, which in percentage would be 6.68%. Okay. Find the probability the washer has a diameter greater than 45. Okay, so now we're going to draw, at the beginning it's going to be the same, right? It's going to be 40 in the middle, 42, 44, 38, 36. And now they're saying, okay, from 45 to and greater. So greater than 45. So that would be here to the right, right? It would be this area here. So basically that means we want to know the area between 45 and infinity, positive infinity. So we could do that by doing second dist, normal CDF, and we're going to say 45 and 1 EE 99, which would be positive infinity. And the mean is 40 and the standard deviation is 2. And our percentage would be 0.621%, very small. Okay, or we could just put 0.00621. Every week 300 washers are tested. Calculate the expected number of washers that have a diameter between 35 and 43. In this case, they're asking for expected number, but don't be fooled. First, what you want to do is find the probability. After you find the probability, then we are going to find the expected number. Let's find the probability first. So in the middle we have 40, then we have 42, and then we have 44, and here we have 38, and here we have 36. Okay, And so they say they want to know what's the probability to fall between 35 and 43. So 35 would be right here. 43 would be right here. So they're saying what's the probability to be between these two? And so I'm coloring it in the region here. So this is 35 and this is 43. So we're going to find the chance that it's going to be between those two using the calculator. Since it's not exactly on the standard deviation line, we can't use the 68, 95, 99 rule. So the lower limit is going to be 35, and the upper limit is going to be 43. And so the percentage is going to be 92.7% chance. So the percentage chance that the washer is going to have between 35 and 43 millimeters diameter is going to be 92.7%. Okay, but they want to know the expected number of washers. So we know that 92.7% of the washers are going to be in that size, but how do we figure out how many washers we can expect to have that size? Well, luckily at the beginning, or not the beginning, but in the middle, they tell us that 300 washers are tested every week. So we know the total number. All we need to do is multiply 92.7% times the total number of washers. And to do that, it's almost easier just to keep the decimal instead of making it into a percentage. So we're going to multiply that times 300, and we're going to get a number that's very close to 300. We're going to get a number 278. And we're just going to round that to the nearest whole number, 278. So we'll say the answer for C is going to be 278. In a certain school, the monthly incomes of members of staff are normally distributed with a mean of 2,500 euros and a standard deviation of 400 euros. Sketch a normal distribution diagram to illustrate this information. Now, in this case, they're actually asking us to draw it out. I think it's a good idea to draw it out all the time, even if they don't ask you. Okay? So 2,500 is the mean, standard deviation is 400, so the first standard deviation line is going to be 2,900, and the left standard deviation line is going to be 2,500 minus 400, which is 2,100. Okay, so here we would have 2,900 plus 400, which would be 3,300. And then here we would have 2,100 minus 400, which would be 1,700. Okay. Now let's go on to the question. Find the probability the member of staff earns less than 1,800 euros per month. The school has 80 members of staff. Earns less than 1,800. Let's mark 1,800 here. It's kind of like here, closer to 1,700 than 2,100. So we're trying to find out the probability that they earn less than 1,800. So that would be so negative infinity to 1,800. Okay. So let's put the numbers into the calculator and figure out what that's going to be. Oops. Second distribution, normal CDF. And the left boundary is negative infinity, so we put negative 1 EE 99, and the upper boundary is going to be 1,800, and then the mean is going to be 2,500, and the standard deviation is 400, and that's it. So the answer is 4.01%. Okay, so 4.01%. Okay. The school has 80 members of staff total. Calculate the expected number of staff who earn more than 3,400 euros. Okay, so let's draw the numbers out one more time. So we have 2,900, or 2,500 is the mean, and then the next number is going to be 2,500 plus 400, which is 2,900, and the left standard deviation line is going to be 2,500 minus 400, which is 2,100, and then this will be 3,300, and this will be 1,700. Okay, and they're saying calculate the expected number of staff who earns more than 3,400 euros. 3,400 would be about here, and then more than 3,400 would be from here to infinity. So even though they say find the expected number of staff, first we want to find the percentage. So we're going to put second distribution, normal CDF, and we're going to put 3,400. 3,400, and we're going to put the positive infinity here, and then the mean and the standard deviation are already there. Okay, and so it's going to be 1.22%. 1.22%. But they ask us the expected number of staff, not the percentage of the staff. So they did give us the total number of staff. So we just multiply this total number of staff times the decimal, not times the percentage unless you multiply, divide by 100. And that's going to give us 0.978 members of staff. So basically that is almost one staff member. So we could just say one staff member. Okay, so be careful, the decimal there means like almost one person. I won't do number 5 for you because it's pretty much like the last two. Number 6, I'm just going to set it up for you. At a market, the weights of bags of kiwi fruit are normally distributed with a mean of 500. We're going to draw a picture again. And a standard deviation of 8. So that means here it's going to be 508. Here it's going to be 492. A man picks up a bag of kiwi fruit at random. Find the probability that the bag weighs more than 510 grams. So that would be here, right? 510 to infinity. Okay. So you would just put that in the calculator using 500 as the mean, 8 as the standard deviation, and then the left and right boundaries would be 510 and infinity. And that's how you do that.